Welcome, my name is Lexi Rowland. I am a member of the Kadaster Data Science team working on linked data and the Kadaster Knowledge Graph. With this tutorial, I'd like to take you through how to explore and query the data that is contained within the Kadaster Knowledge Graph using a set of tools that we offer. The best place to start is at the landing page for the Kadaster Knowledge Graph, data.kkg.kadaster.nl, where we provide a short overview of what the Kadaster Knowledge Graph actually is. And if you scroll down, you see a set of tools that you can use to access and to explore the knowledge graph. Today, I'll be focusing specifically on the SPARQL editor and on the data model. And it's important to note that I won't go into any specifics on SPARQL itself. If you would like to brush up on your SPARQL skills, please feel free to look on YouTube. There are plenty of tutorials that will help you with this. I will start small and get more complex, but I'm really focusing on how you can use SPARQL to explore the Kadaster Knowledge Graph. What is handy is to open two tools. The first is the SPARQL editor, and the second is the data model. We'll be using both over the course of this tutorial. If we go to the SPARQL editor itself, you'll see I have already prepared a very basic question, a very basic query, in this case, a simple SPARQL query. And if you run this query, you will see a set of random triples returned about what contained in the knowledge graph. In this case, the filter or the limit is on 100. So you get quite a lot of information, and perhaps you already get a feel for what classes are within the knowledge graph. Not too much information on the attributes, however. So let's first, we'll just pick something that might be interesting. Working with geographic information, so let's take a name for a geographic object. In the Netherlands, there is a municipality named Apeldoorn, so let's use this as the starting point. If we use the string Apeldoorn and we run this query, we can already see the set of triples where the object is the string Apeldoorn. And this provides you a little bit more information. So starting from the top, you see there's a list where apparently a string called Apeldoorn is also included. But you start to see a little bit more detailed information that there is apparently a municipality area called knowledge graph, called Apeldoorn. There's a woonplaats, also called Apeldoorn, and that you see there's a number of addresses that also have a place name called Apeldoorn. Let's pick one of these attributes and query the knowledge graph further, exploring what might be related. So EMXGer naam, let's use that as an example. And here you will see all triples where the predicate is naam and the string is Apeldoorn. And this becomes a little bit more specific. So now we really see that there are apparently three types of organizational areas called Apeldoorn on different levels. So here we have a municipality and also a living area. Is the direct translation. But what's interesting is you can already see that there's double. So you would expect that there's an area or a municipality where Apeldoorn is a unique name. However, this is not the case. So perhaps we'd like to explore this a little bit further. The best way to do this is to pick one of these URIs up, go to the triple store environment that you opened, and drop this URI into the browser. Here you see a visualization of all the triples that is related to this URI. You should read it in a little bit of a tabular form. So this is a woonplaats with a specific identifier. These bold attributes are then the predicates, and these responses, these objects in this case, are then the objects in your query. You could pick any of these attributes up to query it, but what's perhaps interesting is here you see there's a status where the woonplaats is no longer valid. In reality, a lot of use cases would only like to work with valid data, so let's use this attribute to filter out the double or redundant information in this that's being returned in this query. So we use the same prefix, EMXGer in this case, we use status and query for the status of all subjects where they also have the name Apeldoorn. Again, you see 2 woonplaatsen, and here indeed you see 2 different statuses. That is why we had redundant or duplicate data in the previous query. And let's add a filter to only show that status which is now valid. In this case, woonplaats aangewezen. Okay, now we have this subject with the name Apeldoorn, and that has a status of that's got a status of woonplaats aangewezen. You can also just as well add an RDF type, IMXGeo woonplaats, and now you're sure that the result of this query is only returning those subjects which also have a type woonplaats. And you get the same result. You can further refine this query by adding more and more information about woonplaats, but that's probably not yet apparent just based on the SPARQL result. What the best thing to do then is to go back to the triple store environment, and you click on the schema. And this schema provides an overview of the entire data model used for the Kadaster Knowledge Graph. And you can also use the filter or searching function to see what information is related to a woonplaats in this case. If we use the filter function and type woonplaats, you will see only the class, in this case right in the center of the screen, that is an IMXGeo woonplaats with the different attributes and their data types, but also their relations to other objects in the Kadaster Knowledge Graph. If you use this data model as the basis of your SPARQL query, you'll be able to quite quickly come into the flow of querying a woonplaats, but also the same applies for the other object types in the knowledge graph. If we remove woonplaats, for example, and use gebouw, in this case a building, in the Kadaster Knowledge Graph, you will see a similar visualization. And here, perhaps a little bit more interesting information, you can find the building year of a building, the usage function, also the identification or the geometry can all be queried in the same way. All that would require is to adjust your SPARQL query to make this gebouw and apply the different attributes and any filters you might need. I will challenge you to do that by yourself, and we'll continue with building on this query a little bit as we move on. If we go back to the schema, let's take woonplaats again. Woonplaats. Here you see that there are relations from woonplaats to parcels. In reality, a woonplaats has a specific geographical area, of course, so does a parcel, and these 2 geographical areas overlap. So you can say, and in this case, in the IMXGeo model, that the woonplaats and the parcels, they have a relation, and in this case, it's called bevat perceel. So a woonplaats contains a parcel. Let's add this to our query. If we go back to the SPARQL editor and we say bevat perceel, now you will get a full list of all the a full list. In this case, because we have the limit 100, you will get 100 parcels that are related to the woonplaats Apeldoorn, that where the woonplaats is also a valid woonplaats. Of course, if you remove the limit, you will get all of the parcels that are related to a woonplaats in this way. You now have the base query, in this case for the particular object type called woonplaats. Using the combination of the data model and the browser tool, you can expand this to view all attributes related to both woonplaats and perceel. And I'll challenge you to do this, but I would like to take a side step to a new use case. Let's consider that you might like to find the address, all the addresses in a particular postcode so that you can send a letter to these addresses for whatever reason. Starting then with the variable address and using what we already know, address. Let's see if this returns any results. I already knew it would, but in theory, what you could do is go back, use this filter function, remove woonplats, and use the filter, the search function to see whether any information about an address is contained in the knowledge graph. This is indeed the case. There's a list of attributes that you could also use. But just for simplicity, let's also filter this data model to only show the addresses and its relations. So we'll use this as the basis for the creation of our SPARQL query. For the address, you of course would like to have a house number, a house letter, and maybe an addition, and also the postcode, so that you can use that to filter for a particular postcode. So let's start with creating that. For simplicity, I'm going to copy and paste the query into the editor, and then I will take you through this. So what we've done is we've created a variable address that has a type address, also the postcode with the filter. In this case, instead of creating the filter $postcode and then a filter option here below, we've directly included the string in the object position. You've also included house number, the street name, and the place name that's associated with this address. And we have added 2 optional clauses. The reason for this is that not every address has a house letter, and also not every address has a addition. So this needs to be an optional clause. Otherwise, you will only find all of the addresses in this postcode that have both of those things. So you would like to just have all of the addresses irrespective of whether or not they have this optional attribute. Again, a limit 100. For simplicity, you could also remove the limits, but just to reduce the query time in this case, let's put the limit at 20 addresses. And here you see all of the information, all of the addresses in this particular postcode as your response. Now, imagine you would like to also filter to only have the addresses with a particular function. In this case, the function or the gebruikstool is on the building object and not on the address object. Let's see how that looks in the data model. Here you see an address with no gebruikstool. But we do have a relation to a building, and this building here indeed has a building year and also a gebruikstool. And if we would like to filter that we only look at offices in this area, for example, we would need to make first a relation to the building and then and apply this filter. So let's do that in our SPARQL query. You do this by adding a small set of triples. And here you see the relation between the building and the address. And then also adding the filter for gebruikstool, or the variable for gebruikstool in this case. If you would like to add a particular filter, you can do so by either changing the string to, in this case, we can use office function, kantoor functie. Or you could add it as a separate filter as we did with the woonplats. Yeah, this takes a little bit of time. It takes about 20 seconds to do. But now we have a set of 20 addresses that are filtered for only being offices. And now you are able to, in theory, start sending your letters to these particular addresses. However, it's obviously handy to then also have this in a human readable way. You can also add this to your SPARQL query. Let's take a look at how that might be done. You can do this by with a combination of bind and concatenate. And I will just copy and paste that into the SPARQL query. Here you see a bind function with a concatenate of different variables. So we're concatenating the string, the street name, the house number, and a couple of other variables, in this case postcode and woonplaatsnaam. But because we have these two optional clauses, house letter and house number toevoeging, we need to first add a conditional clause to this concatenate. In this case, if the house letter is bound, then add the house letter to the, in this case, adresregel, this description of the complete address. And if not, then leave it blank. That's what we're basically adding with this if function. You can do this for all optional clauses. And at the end, if we run this query, it will take a bit of time. But when we run this query, we will get one long string with the complete address of all of these individual addresses that we see now in columns. It should be in one column in a string. And you can then use this on a letter to then fulfill your use case. Okay, with this query, we have touched quite a lot of SPARQL functionality, but we've also been able to explore the knowledge graph, both using the SPARQL editor, but also the data model explorer. Please feel free to expand on this and to apply your own use cases to this using, I think, basically the workflow would be to start with the data model, explore what you can and can't find in the data model, and then use this and apply this to your SPARQL query. Also just note that the prefixes, you might have two different prefixes depending on what attributes, what models have been applied. The best thing to do would be to explore the individual instance data and see what's been applied to the instance data. So this is easy to do. If we use an address as an example, here you'll see the information relating. This is the data model, but then if you use the back button, you can then see the individual instance data that is typed as an address, and you can start to see the different attributes, and you will start to then also see that this, for example, is the EMXKO core vocabulary. But that a number of other vocabularies are also added. So was derived from is not an EMXKO specific attribute, but is a provenance, an international standard ontology. So just make sure when you're querying, if you're not seeing results, just make sure that you're using the right vocabulary, the right prefix, and add those prefixes here in your SPARQL query. If you have any questions, please feel free to send me or the rest of the team an email, and we'll be happy to help you. Just to round off this tutorial, just a quick overview of what else you might be able to do with the Kadaster Knowledge Graph. We as Kadaster, of course, geo information is super important to us. So it's always nice to see some of this information visualized on a map. I already pre-prepared some of these queries, but just to give you some inspiration, here is one example of the combination of address information and buildings by then viewing their geometries on the map. So the geometry related to an address is always a point that's based on the underlying key register, in this case, the key register of addresses and buildings. And if we then make the relation to the building year has a polygon relation. So if we scroll down to this result, you'll see both the polygon visualized on the map and the point. And this address looks very similar to, or this SPARQL query looks very similar to the previous SPARQL query that we've written, adding the geometry, for example, but also the building year. And we visualize all of this on the map using the geo widget. You can change the color of the polygons. In this case, I've used green. And with the bind concatenate function, again, you can create a little widget. To see how this works, please go to the Yaz GUI documentation, and you can do this yourself as well. If I click on the address, you'll see a little pop-up. This gives the address of the building, the size of the floor size, and also the building year in which this building was built. So you have both the querying functionality, but also the visualization functionality with this tool. And another nice example. And this query looks a little bit more complex than what we were looking at before. But if you go through it slowly, you'll see that you're able to create this yourself, of course. And here we make several links. So we go from address to building to find building year, but then also the building type. We connect to the parcel, and the limitations. In this case, the limitations are the limitations on what you can and can't do on your parcel. That's also written in data, and you can query this here. And what you see on the map is based on a certain street. In this case, Emmeline in Apeldoorn. You can see the different limitations that these parcels may have. Not every parcel in the Netherlands has a limitation, and you can see that very clearly here. Only these green parcels have a limitation, and if you click on the parcel, you can also then see the limitation itself. This visualization is nothing more than a visualization of the data using a specific widget functionality. Again, look to the YASGUI documentation to see how you can do this. But this makes your SPARQL queries a little bit more exciting and communicatable to others. Of course, a nice map is much better than a SPARQL query for some people, of course. Thank you very much for your attention. Again, if you have any questions, please feel free to contact me or the rest of the team, and we'll be happy to help you explore and make use of the Kadaster Knowledge Graph. Thank you.